My dear students, welcome to Easy BTech, your guide for BTech and beyond. We are discussing about signals and systems subject, and today's topic problems on Fourier transform. Very important topic we are going to see, and all of you follow the channel and watch videos regularly, subscribe. So please do it so that you can understand all the subjects related to all engineering branches. You can understand easily, you can understand well. So let's start our session. Problems on Fourier transform. Very important problems we are discussing. So already we have seen some problems in the previous session. Still we have problems we are going to do on Fourier transform. So let's take the problem. Find Fourier transform of, the problem is find Fourier transform of e power minus at t into e power minus at u of t. Very important problem. So this exponential function is multiplied by t, right? It's Fourier transform we want. So as already we discussed, most of the problems we can solve using properties. So here we have property related to this problem. That property I am writing. Frequency differentiation property. That is very helpful here, or we can do it using frequency differentiation property. Frequency differentiation. Whenever you have into t, the signal is multiplied by t. So we can do that Fourier transform. Such problems we can do frequency differentiation property. So what it is saying that x of t is the signal, its Fourier transform is x of omega. Then differentiation in frequency, that means d by d omega of x of omega. So x of t is multiplied by minus jt. X of t is multiplied by minus jt. Here also multiplied by t. Right or not? Same situation here also we have. So what is x of t? What is x of t? E power minus at u of t. Right? So first we take the Fourier transform of e power minus at u of t. Then we apply frequency differentiation property. We have solution. So let's take e power minus at u of t Fourier transform. So already we discussed it. What is the e power minus at u of t Fourier transform? 1 by a plus j omega. 1 by a plus j omega. So this is x of t, this is x of t, and this is x of omega. Now we have to differentiate the x of omega. So I am going to do that. So d by d omega, differentiation with respect to omega of x of omega. X of omega is 1 by a plus j omega. 1 by a plus j omega. So what will be the left side? So e power minus at into u of t into, we get minus jt. Right? Minus jt is coming. As per the property, it is there. So what is the differentiation of 1 by a plus j omega? So it is like 1 by x, d by dx of 1 by x. So what is the differentiation of 1 by x? Minus 1 by x square. So the right side I am writing differentiation minus 1 by a plus j omega whole square. Again a plus j omega differentiation. A differentiation is 0. J omega differentiation is j. Differentiation with respect to omega. So you get j. So left side we have minus jt e to the power minus at u of t. Right? Okay. So nothing is there. Just a simplification. So minus minus get cancelled both sides. J get cancelled. Then t into e power minus at u of t. Its Fourier transform will be What is the Fourier transform? 1 by a plus j omega whole square. This is the Fourier transform. Very, very simple, right? So similar way, I want Fourier transform of t into e to the power minus 2t of t. T into e to the power minus 2t e of t. What is the Fourier transform of t into e power minus 2t e of t? So in the place of a we are seeing 2. So then the answer is 1 by 2 plus j omega whole square. 1 by 2 plus j omega whole square. So properties, if you thorough in the property or in properties, if you are well known, if you know well about properties, then problems we can do easily. By practice we can do easily. Let's go to another problem, another important problem. So Fourier transform of 2 by 1 plus t square. What is the Fourier transform of 2 by 1 plus t square? Same property. Duality property is helpful now. So duality property, and we can call it is symmetry property, duality or symmetry property. So what it is saying that x of t Fourier transform is x of omega, then capital X of t Fourier transform will be 2 pi small x minus omega. So Fourier transform pair I am taking. So in the place of x of t, what will be the x of t? If you understand that x of t, if you think that x of t, this problem you can do easily. So we already know e power minus a mod t Fourier transform. This signal Fourier transform already we know, e power minus a mod t. So what is the answer? 2a by a square plus omega square. So the denominator is like a square plus omega square. That is why e power minus a mod t is the signal. Okay. So now the take duality property, apply duality property. Now 2a by a square plus t square, because omega is t now, right or not? See this cross arrow. So its Fourier transform will become 2 pi into e to the power minus a mod, here small t will become minus omega, so mod minus omega, 2 pi into e power minus a mod minus omega. Just a simplification, go for simplification, then we can get the answer. So I am going to simplify this again. So both sides we have 2, we can do cancellation of 2. So now a by a square plus t square, its Fourier transform is pi into e to the power minus a mod minus omega is mod omega. Okay, okay, mod minus omega is mod omega. Now we want Fourier transform of 2 by 1 plus t square. 2 by 1 plus t square. So let's take a is equal to 1. Take first a is equal to 1. Substitute 1 by 1 plus t square, right or not? 1 square is 1 only. So its Fourier transform will become pi e to the power a value 1, therefore e to the power minus mod omega. But we want 2 by. So what is the 2 by? Just take 2. So now multiply both sides by 2. Then 2 by 1 plus t square Fourier transform will become 2 pi e to the power minus mod omega. That's all. Right or not? So see how properties are very helpful to solve problems easily. That is the power of properties. That is the use of properties. Another problem. find Fourier transform of e power minus 2t u of t minus 1. Fourier transform of e power minus 2t into u of t minus 1. E power minus 2t into u of t minus 1. So how to do it? E power minus 2t into u of t minus 1. How to do it? So here we have t minus 1, and here in the exponential we have e power minus 2t. In the exponential we have e power minus 2t. So what I am doing, just a simple modification of the problem. So e power minus 2 t minus 1 u of t minus 1. So in the place of t I am taking t minus 1. So e power minus 2t and e power plus 2, right or not? So I am taking e power minus 2. So the problem we can write like this: Fourier transform of, just I modified the problem like this, because here we have t minus 1, here we have t. So both must be t minus 1, then we can use property, right? So now e power minus 2 t minus 1 u of t minus 1 e power minus 2, right? So the same we get, the same above we get. So this is a modification, then we can proceed. So we know Fourier transform of e power minus at u of t, already we know it. So we have done previously that. I am taking Fourier transform of e power minus at u of t. So what is the answer for this? E power minus at u of t Fourier transform, 1 by a plus j omega. 1 by a plus j omega. And we have time shifting property. What time shifting property is? Because here t minus 1, time shifting. So time shifting property we are using, or we are taking time shifting property. X of t Fourier transform is x of omega. X of t minus t naught Fourier transform. X of t minus t naught Fourier transform will become, what it will become? X of omega into e to the power minus j omega t naught. So this exponential term is multiplied by x of omega minus j omega t naught. Here minus t naught in the power also minus j omega t naught. So this is helpful now for our problem. Time shifting property is helpful. We are going to apply this time shifting property. So in the place of t naught, what we have? 1. 1 is there in the place of t naught. And in the place of a, we have 2. Right? So this will be a, and this will be 1 is the t naught. So we have clarity, then we can write the answer. So its Fourier transform is, so this e power minus 2 is outside. E power minus 2 is outside. Then x of omega, what is x of omega here? 1 by a plus j omega. 1 by a plus j omega. So here 1 by a, what is the a value here? 2 plus j omega, 1 by a plus j omega, here 1 by 2 plus j omega, into e to the power minus j omega t naught. So you get e to the power minus j omega t naught. T naught is how much? 1. So e power minus j omega. This is the answer. That's all. right or not? E power minus a t u of t Fourier transform 1 by a plus j omega. So in the place of t we have t minus t naught, that is Fourier transform of e power minus a t minus t naught into u of t minus t naught, u of t minus t naught. So it will become, what it will become, time shifting property, what it is saying, 1 by a plus j omega into e to the power minus j omega t naught. So in the same, the problem also same manner. So in the place of a we have 2 and in the place of t naught we have 1. So here 1. So this is the answer. This is the answer. Right? Here we can take bracket. Okay. So answer I can write like this. E power minus 2 e to the power minus j omega simplification divided by 2 plus j omega. So here bases are same, so we can add powers, e power, and minus also you can take common. So 2 plus j omega, right or not? 2 here j omega, so 2 plus j omega divided by 2 plus j omega. So this is the answer. Okay, let's go to another problem, another important problem. Find Fourier transform of sin t by pi t. Sin t by pi t. So this Fourier transform we are going to do. So how to do it is, already same duality property. This is also from duality property. Duality property. So already we know rectangular function. Rectangular function of width tau. Its Fourier transform already we know. Suppose amplitude is a rectangular t by tau. So that is in terms of waveform. So the width is tau, means left side minus tau by 2 and right side plus tau by 2. So total width of the rectangular pulse is how much? Tau. And amplitude is a. So this is the signal. So its Fourier transform, this is x-axis is t. Its Fourier transform already we know, 2a by omega sine omega tau by 2. So already completed this problem. So the Fourier transform is how much? 2a by omega sine omega tau by 2. Okay. Now apply duality property to this, because here we have sin t. So sin is available in rectangular function. So this is the idea. This is the clarity. Now take duality property. So let's take a value 1. Suppose amplitude is equal to 1 here. So here also a value, only a value, amplitude is 1. So now duality property 2 by t. What the duality property saying? I will write the definition here, then we follow it. So x of t Fourier transform is x of omega. As per duality property, capital X of t, its Fourier transform will become 2 pi small x minus omega. Okay, this is the duality property. So this property we are going to use. Now wherever omega is there, take t. So 2 by t, amplitude is 1, I told you already, so I am not writing a is value 1, let's take a is 1. And the sine omega means t, tau by 2. So its Fourier transform will become, so here rectangular, amplitude is a, that is why I am writing rectangular. In the place of t, minus omega will appear, so minus omega by tau and into 2 pi is multiplied. So 2 pi rectangular minus omega by tau. So here into 2 pi. So just duality property we are following or we are using. So this rectangular function is a even function. The width is tau, therefore it is a even function. So in the next step, I am coming here. In the next step, what we can do? So 2 sine t tau by 2 divided by t. Its Fourier transform is 2 pi rectangular omega by tau. Rectangular omega by tau. So here we can cancel 2 both sides, right? Now the remaining is sine t tau by 2 by t, and bring pi left side, it will become pi t. Just pi I am bringing left side, so it will become pi t. Then it will become rectangular omega by tau. Rectangular omega by tau. So means what this indicates, rectangular omega by tau? A rectangular function with omega, the width is how much? Tau. Amplitude is 1, the width is tau. Minus tau by 2 plus tau by 2, total width is tau. So this is the result we have. Now he wants sin t by pi t. So here tau by 2 is equal to how much we need to take to get sin t by pi t? What is the tau by 2 value? If tau by 2 is equal to 1, then we get sin t by pi t, right or not? Then answer will be, what is the answer? Tau by 2 equal to 1 means tau is equal to 2. Tau value how much? 2. So tau by 2 is 1 means width become 2. So tau is 2. So what is the answer now? Please tell answer. Then we get the problem, given problem answer. So take that case, then write the answer. So Fourier transform of, or we can use arrow representation. Otherwise we can write like this. Fourier transform of sin tau by 2 value 1, therefore sin t by pi t is equal to, what is the answer? Rectangular omega by, what is the tau value here? Tau is equal to, so this is the answer. Rectangular omega by 2. If you plot it, a rectangular function, width is 2, means minus 1 to 1, minus 1 plus 1. This is the omega, so this is our answer. Amplitude is 1, right? So very important, sin t by pi t Fourier transform is rectangular omega by 2. If you plot it, a rectangular function, minus 1 to 1, amplitude is 1. Amplitude is 1. Okay. So friends, please follow videos. You can do more problems. We can have more sessions. Please follow the classes regularly. Watch videos regularly. Thank you. Thank you all.